Hi everyone, today we are going to talk about the concept of molecular and the empirical formula, and there are a few questions about it which will make it for you much easier in order to solve these kind of questions. Now, the differences between molecular and the empirical formula. What are molecular formula? What is molecular formula? The molecular formula is the number of atoms of each element that are in that specific compound. For example, C4H8 with a mole ratio of 4:8, as you can see in the formula. And there is a tip here that the molecular formula is the actual formula of the compound according to its molar mass. This means that each molecular formula, or let's say each compound, they have different kinds of molar masses, and that's why each element have their different relative atomic mass, and that's why the molar mass is all the times different in different kind of compounds. And in the empirical formula is the simplest or the most reduced ratio of the atoms existing and involving in the compound. Now we have to think about the highest common factor of those elements ratio. So after dividing the highest common factor of the mole ratios, which in this case is 4, and as you know, the highest common factor is the highest number, the highest possible number that those two ratios that, as you can see in that specific example, can be divided into to get the smallest whole numbers. For example, in this case, as now I'm saying, I'm determining that the highest common factor in this case, in this formula, is 4. So after dividing 4 by 4, which is going to be 1, and 8 by 4, which is going to be 2, so this is the most reduced ratio. And after putting those ratios, mole ratios, on the formula, we are going to get CH2. In some cases, different compounds can have the same empirical formula because of their similar elements and mole ratios. As you can see in the picture, the molecular formula, that means there are different compounds which their molecular formula is C2H4, C3H6, C4H8, C5H10 and C6H12. These are different compounds that they exist in the nature. And as you can see, their mole ratio, the highest common factor of them is exactly the same. And when they are going to be divided by their highest common factor, in all of these different compounds, the mole ratio is going to be 1:2, which is going to be CH2. The empirical formula. And because they have similar elements, they have the same elements, and the mole ratios are the same when they are being divided by their highest common factor. In order to solve the molecular formula in a question, we have to know this all the times, which I'm going to explain it with a great example. The molecular formula is the molar mass of the molecular formula divided by the calculated empirical formula mass, which in this case is going to be 60 divided by 30 equal by 2. So the molecular formula is going to be CH2O multiplied by 2. So in this case, we notice that CH2O is the empirical formula. So after getting its molar mass, after getting the molar mass of the empirical formula units, we are going to get 30 for sure. And the molar mass of the molecular formula that we don't know the molecular formula, but we know its molar mass, which is going to be 60. And then by multiplying the answer by each element occurring and existing in the empirical formula, we are going to get the actual formula, the actual amount, the actual quantity of each element, of each individual element existing and involving in the compound. Sometimes there is no highest common factor for the mole ratios except by 1. So the empirical formula will be the same as the molecular formula. So in this case, we know, for example, the molecular formula is going to be P3N5. So there is no highest common factor. The highest common factor is going to be 1 in this case. And as you are going to divide 3 by 1 and then 5 by 1, we're going to get the same thing. So the empirical formula is also exactly the same as the molecular formula, which is not a big deal, it's not a problem. This happens sometimes when these two numbers, or more than two numbers, which according to their elements, they do not have a mole ratio that are going to have a similar relationship between each other in order to have a highest common factor more than 1. And also in the second example, which is named by C5H12, as you can see, there is no highest common factor except by 1. So after dividing these mole ratios by 1, you are going to get the same thing indeed. So let's say there is no highest common factor, or the highest common factor is 1. So the molecular formula is going to be exactly the same as the empirical formula. So now there are two questions that will make it for you much easier. Be patient. Question number 1. Calculate the molecular formula of a compound with the empirical formula of C2H2O. So the empirical formula, we know that the empirical formula is written. We know it. And the molar mass of 126.12 gram per mole. So as we are reminding the formula in order to get the number that is going to be multiplied by the empirical formula in order to get the molecular formula, the actual formula is the molar mass of the molecular formula divided by the molar mass of the empirical formula. So we know the exact formula in order to get the molecular formula. So in this case, what is the molar mass of the molecular formula? It is written. It is 126.12 gram per mole. So we are going to write it in the numerator. And the denominator is written that the molar mass of the empirical formula. So after multiplying the relative atomic mass of carbon by 2, which you can see, it's C2. So we have to multiply the number of the moles by its molar mass by its relative atomic mass in order to get the real mass that we are using. And also the same thing for the other individual elements. And after calculating it, we are going to get 42.04. And after dividing these two, we are going to get 3. This 3 is not the molecular formula, don't forget, since it's not a formula. It's just a whole number. So we have to multiply this number by the empirical formula in order to get the molecular formula. And after multiplying it, we are going to get, so after multiplying 2, which is beside carbon, by 3, we are going to get 6. So C6 until now. And also H, it is 2, since it's a diatomic element. So after multiplying the 3 by 2, we are going to get also 6, the same as carbon. So C6H6 until now. And also O, which is 1, when it is not written, indeed, it's going to be 1. So after multiplying 3 by 1, we are going to get O3. So the final answer, or let's say the actual formula or the molecular formula, is going to be C6H6O3. The second question, calculate the molecular formula for a compound which the empirical formula of it is going to be C2HF. So for C is 2, for H is 1, which is not needed to be written, and also F is 1, which is not written, as usual. And the molar mass of 264.18 gram per mole. So, again, the same thing. We are going to remind the formula with each other, which in this case, all the times, it is going to be the molar mass of the molecular formula divided by the molar mass of the empirical formula. So now, let's determine and discern the numerator and the denominator of the equation. So in this case, the molar mass of the molecular formula, which is written is equal by 264.18. And in the denominator, which is written, the molar mass of the empirical formula, which in this case, after calculating it, multiplying 2 by the relative atomic mass of carbon, and then plus by the relative atomic mass of hydrogen, and then plus by the relative atomic mass of fluorine, indeed we are going to get the exact same number, which is equal by 44.03, which is all the time the same, since the relative atomic mass of these individual elements is not going to be flexible. It's all the times constant, which in this case, after dividing it with each other, we are going to get 6. As I said before, this 6 is not the answer. It's the number that we are going to multiply it by the empirical formula in order to get the actual formula, or let's say the molecular formula. And after multiplying 6 by the empirical formula, we are going to get C12H6F6. Thank you for your attention. Thank you so much. Don't forget to subscribe, like, share, and if you haven't turned on the bell yet, please do it. So see you in our next video.